Ok, estamos ao vivo. Fala, galera, beleza? Boa noite, bom dia, boa tarde aí a todos vocês que estão acompanhando mais essa sessão para o SQL Maniacs. Galera, hoje a gente tem, um assunto que vocês pediram demais, vocês pediram muito, né? Trazer aí assuntos sobre engenharia de dados, data engineering e, a gente tem um cara fera demais para falar sobre um assunto que vocês têm perguntado bastante, que é Spark, tá? Então, eu convidei o Warner e ele aceitou falar para vocês aí um pouquinho sobre essa tecnologia, tá? Eu espero que vocês curtam muito, façam perguntas, tá? Coloque a pergunta aí no chat. No final da apresentação, eu passo as perguntas aí pro Warner. E, galera, vamos aproveitar muito essa oportunidade, tá? So, Warner, thank you again for your time. I know that we are really excited to know more about Spark. I am. I can tell you that. So, you can just start. I just want to say thank you again for your time.
Absolutely.
You can run the show.
All right.
Thank you.
Sounds good. Let me start sharing, and then we can go into my PowerPoint. All right. Share. And let me know if you see my PowerPoint. All right. Hola, galera. Very nice to be here again with the SQL Maniacs. This time I'm going to do an introduction to Spark for SQL Pros. Victor, I understand a little bit of what he said. And he said that a lot of people were asking about this, asking about, how to get into big data. This is where the idea came from. This session is a lot of people over the years have asked me, I'm a DBA or I'm a SQL developer, and I feel like, it's where do I even start with this whole big data thing? There's so much stuff, especially a few years ago, the ecosystem was very fragmented with, the core Hadoop and the tons of different ways of doing things. And it has really narrowed down now into, if you just want to enter the field and call yourself a big data engineer, you just have to know Spark. At least you got to start by learning Spark. So this is why I put it together this session, Introduction to Spark for SQL Pros. It has just a little bit of slides, and then we're just going to do a demo notebook that I have for Spark. We're going to run Spark on Synapse, kind of like showcase a little bit as well how well the cloud, in my opinion, how well the cloud really adopts Spark as opposed to doing Spark on-prem. So let's fire it up. So quick intro about myself. I've been a DBA and consultant for 15 years now. I used to work at HP in Costa Rica. I'm now a solutions architect at Pythian. Pythian is headquartered in Ottawa, Ontario, Canada. I'm honored, just as Vitor, to be a Microsoft Data Platform MVP. Feel free to reach out to me at warchav on Twitter. Check out my personal blog, createdatapros.com. If you have a question, emails, a lot of times people ask me stuff after the sessions through email. Feel free to send something out. It's warner@createdatapros.com. And my company's blog, pythian.com. We have a really good technical blog. Doesn't just cover Microsoft, it covers everything. We have a lot of posts about AWS, Google, Snowflake, even business, the data related topics for business strategy and all kinds of data related stuff. So the agenda is we're going to do an introduction to Spark. I'm going to demo core functionality of Spark, really try to showcase that people, it's something that should be easy to pick up. If you have experience with databases, it's nothing intimidating. Everybody in the SQL space, I feel, should learn Spark, should know Spark, and everybody could say that, they're okay taking on a big data project. I really feel like this is a big market for all of us, and there's a lot that we can all learn. This is a beginner session, obviously, since it's an introduction to Spark, especially for SQL Pros. So keep that in mind. If you already know Spark very well, you're probably not going to learn a lot. At most, you'll just want to see a little bit of the Synapse Spark experience, but that's it. So this is not really for experienced Spark users. This is a beginner session. If you have never played around with Spark, if you just want to understand how Spark works on a basic level, just to get running, then this is the session for you. So I'm going to go over some Spark concepts on the slides. There's not a lot of slides. I just got maybe 10 slides. And then it's just going to be demo. We're going to do maybe about 45 minutes. and then we'll do some questions at the end if there's any questions. All right. So prerequisites, in my opinion, like I said, it shouldn't be really complicated to get into Spark. I think people working, basic experience working with databases and SQL, and some basic knowledge of usual data warehousing, what is ETL, what do people mean when they say big data, right? Like amounts of data, file formats, that kind of stuff is not really complicated. I feel like everybody that has just those basic prerequisites can really learn and have a career, you know, beyond just SQL and into the big data field, especially starting with Spark. Okay. So just a little bit of history. You guys probably remember the term Hadoop, right? No, almost nobody uses that term anymore. Hadoop was released in 2006, and it was all based on two main pillars. It was first was the distributed storage known as HDFS, and then the second big pillar was MapReduce, right, which is the way of running these jobs in massive parallel clusters where the job will send the code to execute on each node, and then it would aggregate back until you got the answer to your query. Now, Hadoop was very fragmented, so there was a lot of ways of doing different things, right? There was, probably some of you will remember some of this. There was a way to write the queries called Pig. There was just the core MapReduce functionality that you could write on Java. There was Hive, which was the structured way to read files and put it into tables in Hadoop. If you wanted to do streaming, you had to use something else, maybe something like Apache Storm. So taking some of those lessons from Hadoop and improving a lot of it, especially in terms of performance, then Spark came into the picture. And the first version of Spark was released in 2014, so it's a 7-year-old open source product. And the whole idea is that Spark joins everything together so that you don't have to learn, 4 different Apache packages to be able to do big data. Instead, Spark does data engineering. Spark can do batch. Spark can do streaming if you want to. Spark can do ML. Spark can support Python. Spark can support Java, can support Scala, can support even .NET nowadays. Microsoft wrote a Spark.NET wrapper on C#. So, there's a lot of flexibility in Spark as well. And it has continued to be developed very aggressively with lots of support. And the version 3.0 Spark actually was just released last year, 2020, and is now available in most of the cloud providers as well. For example, in Synapse, Spark 3.0 is now in preview. Databricks is the same. It's available there as well. So architecture of Spark is an MPP system, right? It's a massively parallel system. So we have a main node that runs the program, and this program has what is known as a Spark context. And the Spark context is basically the configuration of that Spark application that tells Spark where it can submit the jobs that it will be able to run in parallel, right? So there's a cluster manager component, and there's different cluster managers supported. And the cluster manager helps distribute the work to your worker nodes, right? And the worker nodes will run tasks. And the tasks are what actually goes out and interacts with the data itself, right? Back in the day when, we were on the first days of Hadoop and big data, usually these nodes also were responsible for the permanent data storage, and the data was replicated. HDFS always replicated the data. So that a lot of the advantage was, you don't need like a separate storage. All you have is just all these commodity nodes, and the nodes have both the storage and the compute, and that runs in parallel. So that was an advantage. Nowadays, I have to say, I haven't seen anybody deploy a big data cluster on-prem in a very long time. Most people are just doing it in the cloud. And in the cloud, this kind of changes, right? In the cloud, it's actually a bonus to have a separation of storage and compute, because then you pay separate for storage, then you pay for your compute. If you're not running a Spark job, then you don't have to pay for it, right? You just pay for the storage. And then this gives you a lot more elasticity, right? You can grow your storage to massive amounts and just have the size of the cluster that you really need, depending on how much data you actually need for a particular job or report, etc., right? So what used to be mostly local storage now is mostly cloud storage, right? So whether it's AWS, Google, or Azure, usually people will use the cloud storage like Google Cloud Storage buckets or S3 buckets or Azure Blob Storage or Azure Data Lake Gen 2 to be the actual storage. And then the clusters will go up or down depending on the use, right? So why Spark? What's the value proposition of Spark? First is that it's open source software, so you don't have to license Spark separately, and it is portable across platforms. So if you write a Spark job on your Spark in Synapse, you will be able to move it with very little change to your Spark in AWS, for example. All you will need to do is change the references from your Azure Blob Storage to your S3 bucket, and the rest will stay the same, right? So this is obviously a big value proposition, that you're not locked into any particular proprietary format or platform, right? Implicit data parallelism. So you don't have to specify to Spark how it's going to, how many threads it's going to use or how it's going to parallelize the reading of the data, none of this stuff. All that is handled for you. All you have to worry about is on declaring what you want Spark to do. And fault tolerance is included as well. So Spark will handle automatically if a node has an issue and goes down, right? As I mentioned before, it has multiple programming interfaces. So we got the different languages like Python, Scala, Java, SQL, C#, etc. And then the other thing is, because it is an open source software, big community project from the Apache Foundation, there's thousands of libraries and modules and extensibility that you can add to Spark. And on top of that, because it supports some of these other languages as well, then you can basically import Python libraries, you can import Scala libraries, you can import Java libraries, etc., which really makes the platform just like infinitely extendable and extensible, okay? Now, something that confuses a lot of people when I talk about Spark is that there are different flavors of Spark. So there's the open source Apache Spark that you can go in and just download the whole source code if you want. You can even build it yourself, compile it in your laptop. And this is the, by the way, a lot of the vendors, this is what they deploy in their managed cluster offerings. For example, HD Insight in Azure, or if you're using Dataproc in Google, or EMR, Elastic MapReduce in AWS, etc. Or Synapse itself has open source Apache Spark inside as well. Another popular distribution was Cloudera. There was another popular one called Hortonworks. Now Cloudera acquired Hortonworks a couple of years ago, so now it's mostly just Cloudera. I don't see a lot of Cloudera deployed anymore, to be honest. Cloudera was mostly used on-prem, but like I said, most people, I don't really see much of, if any, on-prem big data projects anymore. And then the last one that's really gaining popularity is Databricks. Databricks is cloud only. It runs on the big three providers: Google, AWS, and Microsoft Azure. And Databricks, they have built a bunch of stuff on top of Apache Spark. So the core is the still open source Apache Spark, but Databricks has built a bunch of customizations and proprietary modifications to the Apache Spark so that they offer more functionality, basically. So if you need that extra functionality out of Spark, then you can use Databricks. Databricks also, kind of like Synapse as well, offers a web-based collaboration environment where you can save the notebooks, you can share them with people, and so on, right? So a lot of people opt to go to Databricks instead of using open source Spark if they really want to have, like, the latest and greatest version of Spark. Though keep in mind, if you do go into Databricks and you build a lot of code that is dependent on the proprietary parts of Spark that Databricks has developed, then you are once again basically locked into Databricks. Okay, so why for SQL Pros? Why do I think Spark, again, is good for SQL Pros, or is easy to pick up by SQL Pros, and it really opens the door for SQL Pros into this big data field? First is that the cloud has really simplified, excuse me, has simplified the deployment dramatically. So it used to be a few years ago, if you wanted to have your big data cluster, it was, you had to do it on-prem, you had to buy a bunch of machines, or you have to build like a VM farm to be your nodes, and you had to figure out if you were going to do local storage or if you were going to do like a SAN deployment, and you didn't need it to also have not only storage admins, but then cluster admins, and you would need to, if it was a really big cluster, you had to manage it with some sort of automation layer like Puppet, et cetera, et cetera. Now in the cloud, you can deploy Databricks with a few clicks. You can deploy Synapse with a few clicks. You can deploy any of the cloud provider solutions with a few clicks, and boom, you have a cluster ready to go, and you don't really have or need that infrastructure expertise anymore. So that really makes it way easier to get into. Second is that Spark has really robust SQL support. And when I mean SQL support, I mean the actual language, right? The select, start, from, where constructs, where it makes it really easy to get up and running, right? You don't even have to write Python code a lot if you don't want to. You can do a lot of stuff just with SQL as well. The structured APIs make it very familiar to Database Pros, meaning if you're used to loading data from files and specifying a schema and then doing some sort of querying or modifications to the schema, then Spark's structured APIs will just, it will seem very familiar to you. It will not be intimidating. It will be something that will be easy to pick up. And I'll just show that in the demo in a little bit very soon. And then the other thing is, in my opinion, it's the perfect ramp to get into big data. This is, if you've never gotten into the big data field, this is how you want to start. You want to start just learning basic Spark, and then into Spark, you can then go deeper into some of the other programming languages. For example, some people start just with Spark with Python and SQL, then maybe they go on to more advanced Python, or maybe they learn a little bit of Scala, etc., okay, or Java. All right, and that's pretty much it. So let's just jump into the demo. I have a Synapse environment ready to go to show everybody. So let me go on it. So if you're not familiar with Azure Synapse Analytics, Synapse Analytics is a combined environment that has dedicated SQL clusters and also Spark clusters and also serverless SQL querying service. In this case, I'm just going to focus on Spark. But just to give you a quick idea, this is a notebook I have running of Spark. You can see here it says the notebook says attached to demo pool. So you can have more than one Spark cluster running. You pick the language again that you want to use for your notebook. In my case, I'm using PySpark because I like Python the best. Sometimes I use SQL. If you're not familiar with SQL, if you're not familiar with the notebooks, you'll see here, this is called a magic, which is basically a markup that you add to a cell to tell the notebook how to interpret the contents, right? So you see here, my default language is PySpark, Python. So when I put in this percentage SQL, I'm basically telling the notebook, hey, this particular cell is not Python. This one is SQL. And you can see right from the bat, this looks very, very familiar to what we're used to on like SQL Server databases, right? It says create database if not exists. So right off the bat, very familiar. And the cool thing about these new cloud-based environments is that they all come with browsers for resources and things like this. So you can easily, right away, you can see I have different Spark databases. I can open them. I can look at the tables that are in them. Again, making it really easy to adopt and learn, right? Same as how you do in SQL, I just set myself. You can see here I'm using a use command to set my database as set this music service database as my context. Same as if you were in a SQL connection, right? In SQL, we use the same thing. We say use MSDB, for example, and then you're using the MSDB database. Same context, same content. All right, now here I'm going to show a little bit of Python. So just show how easy it is to get up and running with Spark reading data. So here I have some data in my data lake storage account. This is a Parquet file. I just have to specify same thing, format Parquet. Parquet files, they already have the types embedded inside, so I don't have to specify a schema. I can just get up and running real quick. And then what this does, if you see here, this is a PySpark data frame, okay? And the nice thing here about Synapse and Databricks as well, these modern notebook environments, is it has IntelliSense as well. and it tells you what the functions are, and you can hover over a variable. It tells you what a type is. So here, when you read from a file, you create what is known as a data frame. A data frame is basically a virtual representation of a distributed data set. So it's something that you're going to process and read and manipulate with your Spark cluster. For most people, you have to think of it as a table, basically a virtual table that lives in the cluster as a variable that you can manipulate with your language, right? So if I go in here and just run this cell, what I'm doing basically, I'm just saying, hey, read this Parquet file and then do a show. The show command will just print by default 20 records from the file, and that's all. That's all I'm saying. I don't have to specify anything other than the path of the file and say, do the show command. Let's look at some data. So very, very simple stuff, just to show again how easy it is to get up and running. And you don't have to specify types. You don't have to specify schema or anything like that. Okay. Now we'll see here. I have my file, and we got it's some music related file. I have some artists, some user IDs, and how many times they played songs by those particular artists, right? So as you can see here, you'll see it said job execution succeeded. Spark used 4 executors. So I had 4 worker nodes, 16 cores total. So each one of my worker nodes has four cores. You see here, there's some links. It says open Spark UI. So if you were just running the Apache Spark, this is the web UI that you get native with Apache Spark. You can still access it from Synapse, and it gives you some of the details of the full execution. You can go into them, and it tells you, what they did on the internals of each thing. You can open it up and look at what Spark did internally on its implementation. What did it do? If you want to get to this level, obviously this is like way more advanced. You can look at what each task did, how many megabytes each one read, where the time was spent, etc., etc. So again, this is obviously more advanced, but just to say that, if you eventually get to that level where you are really interested in the internals, then Spark itself, the native Spark provides a lot of visibility into, what it's actually doing under the covers, okay? So that was very simple. Just load a data frame and show 20 records from it. All right. So now I'm just going to show you as well, what does it do if you just have something like a CSV, for example. You can do that as well, right? It supports CSV. A lot of the defaults are very good. Like, you don't have to specify a schema or anything if you don't want to. For example, here I have the names of some artists and how many dollars they sold in ticket sales. And you can see I didn't specify any schema. I just want to get it up and running, load it on a data frame, and that's it. And I immediately can see the data. But keep in mind, I didn't specify any schema, so Spark just decided to read it all as text, right? String and a string. And even though this obviously are numbers, right now it's a string because, again, I just wanted to get the data up and running. I didn't tell it that the second field, the sales, was a number, right? So you can go real quick, or you can actually specify a schema if you want to. I'll do that in a second. Now, the other thing you might be noticing, of course, is that if you're working with an environment like a notebook, and I'm only doing these like show commands, this prints as text, right? So it's okay if you just want to copy paste it, but it's not the most rich output that you can get, right? So there is a display command as well that you can use in the notebook, and then this will give you a nicer output, a more richer modern output. You can sort the columns, right? And in here in the Synapse experience, you can also chart the results. This is very common nowadays in notebook experiences, even if you're using other notebooks like the Databricks notebook or other notebook products like Jupyter notebooks, for example. Most of it is like this. You just do a display of a particular data frame, and you get a richer output that you can manipulate, you can chart, you can export the results, etc., etc. Okay. Now, if I want to specify a schema, there's different ways of doing this. The way that I usually do it is I just do it through Python. So I add the basically what you have to do is you create a new struct that has the different types of what you want. And then when you read, Now I just do a small modification to my read command that I had before from my CSV. And I just have to say the schema is equal to this custom schema object that I created on with PySpark. Okay, I go ahead and run this. And again, this will be very similar to what we just did. It just created a data frame. Note that it's already done, right? Because I just created the data frame and I didn't do anything with it. So this is something else that Spark does that a lot of people, it's hard to get a handle on when you're just starting. So if you create a data frame, I gave the schema, I gave it the path, but I didn't do any actual action on it, then it actually doesn't do anything. All it did was kind of like prepare all the configuration, and that's it. So Spark does what is known as lazy execution, right? Until you do an action that actually needs the contents, the actual data, it doesn't go out and get it. All right, so you can see this finish really, really fast. I can print the schema. And you can see the schema, again, comes back really fast because the schema itself is just a configuration, right? It didn't actually go out. Now I'm going to tell it to show the first 20 records. And now it's going to be the first time where it actually goes out and gets the cluster to work and get the data back. And you can tell as well here in the notebook, when I did just metadata operations, you see there's no output of any actual jobs submitted to the worker nodes. Whereas if I do check the contents, I do have an output here of the job actually submitted to the cluster, right? And you can see here I get my data back in the show, so I just get 20 records. Now you look here, right? I said the sign up string right now. This, for example, is just it's a string. We can do simple modifications. You can do very complex transformations because you have the flexibility of Python to do whatever you want. But just to show real quick, again, something like a really easy transformation that you would do, for example, to just move this sign up string from this string representation into an actual data type. So we can do that here. You can see I'm just basically saying, give me a new data frame, and I want to add this new column called a sign up date, which is going to be the conversion of the sign up string, right? So this is something else that Spark, how Spark works is that the data frames themselves are immutable. So the data frame is not going to be changed on the spot. What it does is that when you redefine it like that, you are creating a new data frame, right? And I could rename this. I gave it a different name, but I could even give it the same name and say, you know, user details is now equals user details with the column. And basically what it does is, to you, it might seem like it's overwriting, but it's not really. What it's doing is just creating a new data frame, giving it the new definition, and then the old data frame will just get garbage collected from Python. I can do this, just run. You guys see here now the new sign up date. It's a date data type. And if we look at the actual contents, we see the conversion was successful as well, right? So very simple transformations here. Again, stuff that for SQL Pros should be really easy to pick up, get up and running, okay? Limit is a little bit like show, but with the difference that this is going to look exactly the same. But with the difference is that show just prints output, whereas limit actually creates a new data frame just with that amount of records. So very subtle difference. But if you're just looking to grab a sample, for example, of data, then you can do a limit command to basically like grab the top and create a new data frame, right? Something else, obviously, so far I've just been reading the data, but it's really easy also to create new tables in Spark. And the cool thing, again, very easy to pick up for SQL Pros. These just look like regular tables. You can query them and use them just like regular tables, right? So I'm going to go ahead here. You see here, if I go to the data, let me expand this. I only have one table here called user artist place partitioned on this on my music service Spark database. So I'm going to go ahead and look what I'm doing here. I'm taking the data frame and then doing a select on the data frame of these particular columns. And then I just say write, save it as a table called user details. Boom, that's it. Okay, nothing complicated again. Very simple. Just want to save it as a table and let Spark do its job. Then I'm going to show you now what it looks like. It's done. And if I open this and refresh this, you see now we have the table there. And then we can just reference that table really easily, and it's now part of the catalog, right? So very, very simple stuff. Again, nothing exotic for people that have been working with SQL databases for a long time. Now, something else that Spark does really well is to work with JSON, but there's a little bit of trick here. So if you look here, I'm just going to load this JSON file, and it has native support for format equals JSON. And I'm going to try to do a display on that. So I'm going to run this, and we're going to see what happens here. It's actually going to fail, by the way. So don't be scared. All right, so that failed. So why is that failing? So the reason why that's failing is actually from the Spark docs. You can get it right away. And it's that by default, Spark expects, when you give it a JSON file, that each line will contain a separate self-contained valid JSON object. Now, if you are obviously have worked with JSON and you have looked at JSON files, most of them are not like that, right? Most of them have the object split on multiple lines, and then a lot of the times when people are working with JSON, it's printed in a way so that each line will have an attribute and the value, and then the next attribute and the next value on the next line. It won't have the single object in a one big massive line, right? So I don't know why the default is like this, but just so if this ever happens to you, you don't have to be scared. It's actually very simple to solve. There's an option called multiline. All you have to say is multiline is true, and that's it. And then the rest is all the same. So I'm just going to run now this again and say multiline is true. And now you can see Spark was able to read my JSON file without problems, and it gives me a data frame that has a representation, a hierarchical representation of that JSON file. So this is another piece where Spark really works really well for unstructured data, or not necessarily unstructured, I would say semi-structured, right? So JSON files are really semi-structured data. It's not completely structured because sometimes we don't really know, for example, how deep a JSON might nest, and there's no actual limit to it. But it does have to follow the rules of JSON, right? So that's why Spark's still able to create a schema, hierarchical representation from it, right? So for example, in my case, there's a root element, and then inside the root, there's a service users element, which is actually an array. And then this array is composed of different elements that don't have a name. So it's just given a struct. They're just structs. And each one has an age, a country, a gender, a sign-up string, and a user ID. Okay, so now we have this. How do we turn it into the tabular representation that we want? Now, if you're familiar with SQL Server, then you probably have played around with JSON with SQL Server. There's a function that Microsoft implemented called OpenJSON. And usually the way that you work with JSON is you pass in the JSON file, and then you do a cross-apply OpenJSON, and then you kind of like define your fields that you're looking for there. So this is kind of similar. So each time you want to go one level deep in the hierarchy, you do an OpenJSON. In Python, what you do is you use a function called explode, right? And explode basically grabs that item that you're passing in, the path of that item that you're passing in, and then turns it into all its children, right? So you can see here, for example, I'm creating a new data frame called JSON flat, and I'm saying, okay, take that initial data frame, that's right here, right? And then explode service users. So what that means is give me the children of service users individually, and just call it users flat. And I'm going to show you guys what that looks like right now. And I'm going to just do a show 5 so it doesn't take a lot of space. So you see how users flat works now, right? So we're kind of getting there, but we're not quite there yet, right? So now I have each user, but it's still a struct, right? Instead of being separate fields. And if we look at what Spark did in terms of the schema, then basically I have the root now. And then what we have is this column called users flat that is a struct, right? Is a denormalized object inside this column. and each one of these structs has an age, a country, a gender, sign-up string, and a user ID. So what do we got to do now is on the next level. So now we're at this level, right, where we have the individual JSON structs. So one level deeper is basically just to select these fields. You guys can see here, users flat dot user ID, users flat dot age, and so on. And I just have to select them out, and there you go. And I'll be able to have my tabular representation, okay, which is what I wanted to begin with, right? Okay, cool. Now, can Spark do XML, for example? XML, especially if you're working with Synapse, the SQL MPP engine in Synapse does not support the XML data type. Even though SQL Server, the actual SQL Server product, does have XML data type, and it has had it for a very long time. I think XML data type came out in SQL 2005 maybe, or 2008. So more than 10 years at this point. For some reason, it's not in the SQL MPP inside Synapse. But Spark, being also inside Synapse, gives you the whole flexibility to do, use Python basically to process XML. So I can read the whole text of the XML. You guys see here, I'm just saying, hey, just read this text, give me the whole text, and just show me some of it, print a schema. And all the schema is going to do is simply create a table that has one column, one field, one row, and it has the entire content of the text file. And it just so happens that this text file in this case is XML, right? So let's do that. And you see here, right? So I have just one column, one field, the string, and that's it. And it's got the XML value inside, all right? So now what do I want to do? Now what I want to do to be able to parse this XML using Python libraries, I want to grab this value and just assign it to a Python variable. So I'm just creating a new Python variable called XML text. And I'm just grabbing the data frame and saying, okay, head, meaning give me the top element, and then just zero array index means give me the first column, and that's it. All right. And then I'm just going to show you here to verify that I did get the value that I wanted inside that variable. I'm just saying, hey, print the first 100 characters of this XML text, and you'll see here, right? So I get users, and I have this user details, and you'll see the XML goes on, right? So now we have the XML in this variable XML text. And now at this point is where we start using the built-in Python XML libraries. So I'm just going to create an object called an element tree that helps me parse XML in Python. So this is not even Spark related at this point. This is where you can really showcase the flexibility and extensibility of Spark, where you can take any Python library basically and interact with Spark with Python, and then move from Python back to the Spark context really, really easily, right? So now I have this variable, and I'm basically saying, hey, this variable is actually an XML, and for each children in this XML, like print the attributes and the tags, because I want to see, just want to verify that this is actually doing what I want it to do, right? So let me run that, and we see here, right? So you can see we're actually getting the different user IDs in the XML. So we're kind of there, but not quite there yet, right? So what do we need to do to solve this whole thing? Well, basically is now that we have this XML that we can parse, we can just do a for loop, right? And then for each one of these children, just get their different attributes, the user ID, the gender, kind of like how we did at the last step with the JSON as well, and then add them to this list, right? And then I can go ahead and run this, and you'll be able to see here, it is going to print us how many it read. So it read 357,000 users from that XML file, right? Again, all using just the XML parsing capabilities of Python, not from Spark. And now, again, we can go back from the Python into the Spark context. I basically just pass in this array that I created in Python and say, hey, create me a data frame from this Python array and give the columns these names, okay? And then I'm going to go ahead and do that. And then we'll see at this point, I'm back into Spark, right? So I'm back into a data frame. And once I'm back into a data frame, then I can basically go back into doing all the other things that I just showed you, right? Whether you want to manipulate the data frame in parallel with Python, with PySpark, or whether you want to query the data frame with SQL, et cetera, right? So we can see that XML with 357,000 different users. Now I was able to, turn it into the tabular format that I wanted, right? By, again, switching back into using Python libraries, then coming back and turn it into a data frame. So back into like Spark native data frame, okay? Now, if you want to actually run queries on top of a data frame, then you can easily do that by either saving them as a table, or if you don't want to save it as a table, then you can create it as a view, for example. So I'm going to create this view, you guys can see here. So I have this data frame called artist place, and I just simply create a view on top of it that has a different name, right? And once it's been created as a view, then I can run SQL against it. You can see here, I'm just running a simple select command, and I get the results, right? And then I didn't have to do anything other than creating a view on top of the data frame, and then it opens up to be able to be queried with the SQL. Okay, and if I want, for example, to grab that view and do something to it, another SQL query, and then save that as well, I can do that too. So in this example, I can materialize in the results again into another Spark table. So I create a new data frame with a new SQL query. You can see here I'm doing Spark.SQL, and then I pass in the query, and that gives me a new data frame. And then I'm saying, okay, take that new data frame and save that as a table, okay? So you can easily do that as well. Go from, data frame, make a view, use SQL on it, then from SQL, create a data frame, and then save that as a table as well. I'm gonna run this as well. You guys can see. It's called Platform Artist Performance. So it should take a few seconds. And once that's done, it should pop up in the catalog. So let me refresh. And we have that new table there now, okay? And the catalog, by the way, this, again, is Synapse or Databricks or any nice modern environment like this. You can actually get the metadata from your tables as well. So something very, very familiar, again, to SQL Pros. All right, and then once I materialized it as a table, I can just run a select command if I wanted to, right? And that's it, right? Very simple. There's also what is known as writing an unmanaged table. I'm gonna run this now, but I do wanna just talk a little bit about the difference. The difference is basically you can tell Spark to write a table on a specific folder, not in the configured Spark data folder. And then in that case, it's known as an unmanaged table, which means is that Spark will keep that metadata for that table, but if you drop the table from Spark, it is not going to drop it from the storage. Okay, so that's kind of what it means. And then if you wanna, just like any other system, Spark also keeps track of its metadata. So I can do like a show command, for example, if I want to see all the tables that I have created in my Spark database. If I want to see the description of a table, I can do a describe command, and then I get the schema of the table. I get some of the other information of the table, like when it was created, the type of file that is using, etc., the location of the table, and all that. Okay. And then finally, something else that people ask all the time is, well, so what can I do with Spark? Because it seems like a lot of it is just about reading the data, right? And I can materialize data from other queries as well. But how well does Spark do with modifications? Well, at the end of the day, Spark is an analytics platform. It's definitely not built for OLTP. There are some big limitations on Spark. table, especially with native Spark. There are some projects such as the Databricks Delta Lake project that are trying to make more fully featured modern implementations of tables on Spark, and those I'm not going to cover those in this particular session since it's just like an introduction. But if you are looking to learn a little bit about some of the extensibility to get more features for Spark tables, then you can just Google Databricks Delta Lake, and that'll take you to a good resource. And it's not the only one. Databricks is the sponsor of this Delta Lake project, but there's other projects such as Apache Iceberg, Apache Hudi, which are trying to do similar things of creating more robust or more fully featured Spark tables as well. But if you do want to do some just small modifications on your own, you can do it. You can insert a particular value in a Spark table. That works. You can insert select into a Spark table as well. That is going to work. You will not be able to update. So this is where the bigger limitations come in, where you usually would have to use something like Delta Lake or Hudi or Iceberg. Is an update does not work. And if you wanted to do a delete, for example, then that does not work either, right? There's no update or delete. Once the table is created, all you can do is add to it, or then you have to overwrite. So in vanilla Spark, overwriting the whole table is the only way to update or delete. But yeah, that's a lot of work. So there are projects like Delta Lake, Iceberg, or Hudi that overcome this limitation. And if you don't have access to any of these, then the best other thing is to use partitioning, which, again, I'm not going to cover here because this is just a beginner session today. But there is partitioning based on folders on Spark, and then you have the option of replacing or overriding a particular partition, but it's still overwriting, right? So if you wanted to just update or delete, then you're basically rematerializing an entire partition. It is not like an in-place one record change like you would do with, let's say, like a SQL Server table, okay? But again, these other projects like Delta Lake, Iceberg, or Hudi, they are coming in to try to attack some of these other limitations on the native Spark, okay? All right, that's pretty much all I had, I think, at this level. Let's just do a quick recap, and then we'll do some questions. Hopefully, the whole intention of this is to show people that it's something that is not crazy. It has improved a lot from the Hadoop days, so that Spark is really now taking the world of big data by storm. It is the de facto open source engine that most people use today when they think of, what's going to be my data lake for semi-structured or unstructured data. The strengths of Spark, obviously, is the openness, the flexibility, and just the massive amount of libraries that let you do pretty much anything that you can think of. And with a bit of studying, a little bit of practice, I believe anybody can pick it up, and then you can add it as your big data toolbox, right? So you go from just being SQL developer to being able to call yourself a big data engineer, big data developer. It opens up a whole new field for you and your career. All right, so any questions, anybody? I don't know, Vitor, do we have anything?
Hey, Warner, let me just check here. No, we don't have any questions, sir. Nothing yet. Everything is okay. We have some people say that it was a great session. I also agree that, guys. I think that was amazing. So Warner, thank you again. For sure, if we have questions, I can send them to you, or guys.
Yeah,
If
just
you'd
feel
like.
free to reach out on
Yeah.
my contacts, anybody, if you want to talk a little bit about this more in detail, or feel free to add me on LinkedIn as well if you want. Just search for my name, you'll find me. So If anything comes back later, yeah, just reach out on Twitter, LinkedIn, or email, and I'd love to hear from you. And again, hopefully, all I want is to get people motivated and get everybody learning and kind of like everybody expanding the reach of our careers. All right. So have a good night, everybody. And
Thank you again,
until next time. Yep. Thanks for watching.
Thank you, guys. Galera, obrigado. Bom descanso para vocês. Qualquer coisa, estamos aí. Até a próxima, galera. Até mais.
Próxima.